Hi, today we're going to be talking about the tryptophan Operon, which is responsible for the production of tryptophan, a protein that serves as a building block for larger molecules and is essential for life. This Operon occurs in prokaryotes and begins with a promoter, includes an operator, which will bind to a repressor, which we'll talk about later, and encodes for multiple genes, which then translate into proteins, which then become tryptophan. So, if there's not enough tryptophan present, then a RNA polymerase will come in and it will transcribe all of these genes. However, if there is a high concentration of tryptophan, then one of these tryptophans will bind to this repressor, and then this will change the structure of the repressor and will make it able to bind to the operator. If it is bound to the operator, then when RNA polymerase binds to the promoter, it won't be able to move forward because it will be physically blocked. It will fall off, and further transcription will not be possible.
Next, we will dive deeper into the leading sequence. The leading sequence codes for 3 attenuating sequences, 2, 3, and 4. As the RNA polymerase binds to the promoter, it goes through the operator and then through the leading sequence. Attenuators help to fine-tune the amount of tryptophan that is present and that is made. When there is low tryptophan present, then the ribosome is able to take the mRNA sequence made from transcription, and it is able to go through and form a sequence of tryptophan. This right here is called an anti-terminator hairpin, and the ribosome is still able to go slowly through the mRNA sequence in order to make this tryptophan. When there is a high amount of tryptophan present, then the ribosome goes quickly through, which allows this terminator hairpin to form, which does not allow tryptophan to be made, and it causes the ribosome and the RNA polymerase to fall off so that no more tryptophan is unnecessarily made. So, what would happen if there was a mutation in one of the proteins? Normally, the function of a repressor when there's high tryptophan is a tryptophan will bind to the repressor, causing it to bind to the operator, blocking RNA polymerase from transcribing the DNA into mRNA. If there's a mutation in the repressor causing it to be absent, then the high amounts of tryptophan in the cell have nothing to bind to. Thus, even with high amounts of tryptophan, the RNA polymerase will be able to transcribe DNA to mRNA. This could lead to more tryptophan than necessary being present in the cell and wasteful energy expenditure, which could lead to a metabolic imbalance.